Hello everyone, welcome back to our online session. What we study in our last section? We study position, displacement and path length. Motion is represented by position time graph. Such a graph is powerful tool to analyze and represent different aspect of motion of an object. I can show you different types of position time graph. Here is, I can show you one graph. In y-axis represent distance in meter, in x-axis represent second in time. Graph is parallel to the x-axis. Here you can see in x is equal to 40 meter, your object is in rest condition. Means with respect to time, your object not move. Another graph I can show you. It is straight line with respect to x and y. What it means? It means object is moving equal amount of distance, object is covered equal amount of distance in equal amount of time, means it is in uniform motion. Now let us consider third graph, a car travel graph with respect to position and time. Car is starting position t is equal to 0 to t is equal to 10 seconds. Then after t is equal to 0 to t is equal to 20 seconds, car is in uniform motion. Means equal amount of distance traveled by car in equal amount of time. And then brake is applied, means car is in rest condition. Now we can derive another physical quantity in a motion in a straight line. It is average velocity and average speed. First of all, what is average velocity? Why we derived average velocity? Motion is a change in position with respect to time. But how fast an object moves with respect to time? We cannot define. For this, we define average velocity. First of all, what is average velocity? Average velocity, it is a displacement upon time interval. What is displacement? Displacement is a ending point minus starting point. Another word, average velocity is equal to change in position with respect to time interval. That's why V bar is equal to delta x upon delta t. What is delta x? x2 minus x1. What is delta t? t2 minus t1. Time interval, time difference. What is, where x2 is equal to ending position, x1 is equal to starting position. What is t2? t2 is a ending time, and what is t1? t1 is a starting time. Here I can show you one graph. In graph, one point is p point, second point is p2. What is the average velocity between p1 and p2? What is the average velocity between p1 and p2? p1 point is starting point and p2 point is ending point. That's why average velocity is equal to displacement upon time x2 minus x1 upon t2 minus t1. Suppose p2 is in 40 km, p1 is in 20 km, p2 is in time, t2 is equal to 6 seconds and t1 is in 2 seconds. Then average velocity is equal to 40 minus 20 upon 6 minus 2 is equal to 20 upon 4 is equal to 5 meter per second. Now average velocity is positive or negative depending on the sign of the displacement. Displacement is positive, then average velocity is positive. displacement is negative, then average velocity is negative. Here we show different types of graph for average velocity. First graph shows linear, means straight line graph. It shows displacement is positive, that's why average velocity is equal to positive. Now second graph is downward direction in x, that's why displacement is negative. How? Here starting point is x is equal to 40, ending point is x is equal to 20, that's why displacement is equal to 20 minus 40 is equal to minus 20, that's why displacement is negative, that's why average velocity is negative. Third graph is straight line parallel to the x-axis. It shows displacement is 0. Why? Because with respect to time, your position is not changed. Now, average velocity is depend on the displacement. Earlier we seen magnitude of the displacement may be different from actual path length. To describe the rate of motion over the actual path length, we introduce another physical quantity, that is average speed. What is average speed? Average speed is total distance covered by object upon time interval. In other words, what is average speed? Average speed is equal to total path length upon total time. The SI unit of average speed is same as average velocity is equal to meter per second. If displacement and path length are same in magnitude, then average velocity and average speed is same in magnitude. Thank you very much for today's session. We will meet in another session. Thank you.